Welcome to Dr. Bala's Chemistry. I'm your Dr. Bala. So here we are going to discuss the very important topic, that is stereochemistry. So in which the stereochemistry will decide the factor whether the compound is optically active or not. We can check with that. Okay. So here optically active. What is the optically active? Optically active molecules. So how you can check optically activity? So the optical activity can be decided by the chiral carbon. Chiral carbon. So what is the chiral carbon? The chiral carbons are nothing but they are non-superimposable. Superimposable mirror images. Okay. So here the chiral carbon, how we can define it? So here if a carbon, it should be a chiral carbon, that time it should be attached. So here the valency of carbon is 4, that you know very well. So the valency of carbon is 4. Now the valency is 4, if it is attached with the 4 different groups, that time this carbon is called chiral carbon, or otherwise it is called the stereocenter. So it is always called as a stereocenter or chiral center or chiral carbon. So CHI or chiral carbon. We can say all these ways. Okay. So maybe a stereocenter, maybe a chiral center, maybe a chiral carbon. So if it is a chiral carbon, 4 different groups, that time it decides that it is a sp3 hybridized carbon. The carbon is sp3 hybridized carbon now. Okay. Now if it is a sp3, what will be the structure? The structure will be tetrahedral. Tetrahedral in structure. Are you able to understand, students? It's a very, very simple concept. So here if a molecule should possess the optical active, that should be having a chiral carbon. If it is a chiral carbon, then what is a chiral carbon? So the chiral carbon which possesses 4 different groups on its valency. And it is a non-superimposable mirror images also. Okay. And if it is a 4 different group, it is a sp3 hybridized. If it is a sp3 hybrid, that molecule should be a tetrahedral in nature. Are you able to understand? Okay. Now, let's discuss about the tetrahedral structure. Okay. Now, let's discuss this tetrahedral structure. So here, I am checking a carbon. This is the chiral carbon inside. So here, if I am having COOH group, and here I will be having CH3. Okay. And here also I will be having OH group. And this is what I will be having hydrogen. This is what is that? What is the structure of this one? This is the structure of tetrahedral molecule. If it is a tetrahedral molecule, okay, 4 different groups are there. What is the name of this molecule? The name of the molecule is lactic acid. Okay, it is a lactic acid. Or otherwise, we can name it. So here 1, 2, 3, 2-hydroxypropanoic acid. 2-hydroxypropanoic acid, we can say that is a lactic acid. Okay, right. So what did I say? Actually, if a molecule said to possess a chiral, that also we consider as a non-superimposable mirror images. So if I am taking a mirror image of this one, let you consider I am taking a mirror image of this one. What will be the mirror image? So here I will be having COOH. Okay, right. And here I will be having H. And here I will be having OH. And here I will be having CH3. Are you able to understand? This is not a, suppose, what is a chiral carbon? So if it is a chiral molecule, so if a molecule is said to possess chiral, so they are non-superimposable mirror images. How we can say? So here you consider this is my hand. So if I am taking a mirror images here, if I am putting a mirror here, the mirror images will be like this. Okay. If I am superimposed on that directly, they are non-superimposable. If it is a non-superimposable, they are said to be optically active molecules. Okay. They are optically active molecules. Are you able to understand, students? So here, if a molecule is said to possess 4 different carbon atoms. So if I am having a carbon atom, around that 4 different groups are there. That molecule is said to possess chiral center. If it is a chiral molecule, they are optically active. Okay. Now I will be going to explain the small examples like this. So here, students, So here you assume that this will be a tetrahedral molecule. So if it is a tetrahedral molecule, so having this as a carbon, this green ball will be considered as a chiral center or stereocenter. It's a carbon. Okay. So surround that carbon, around that carbon, one yellow ball is there, one red ball is there, one violet ball is there. Top of that, I'll be having one more color ball is there. You just assume it. Okay. Right. Now, let us discuss with the examples. So you just consider this example. Okay. So here I am having a green ball. This green ball will be considered as a chiral carbon. And the left side I am having the CH3 group. The violet ball will be considered as a CH3 group. Okay. And one will be in back side, one will be in front side, one will be in back side, one will be in front side. So H, OH respectively are there. And the top of that I have COOH group. You just assume that COOH group is here. If the molecule, if the carbon is said to possess a chiral carbon, so the valency should be completed by 4 different groups. So our condition is satisfied. Okay. So here one group is there. So it is different, this is different, this is different, this is also different. 4 different groups are there. That's what this carbon is called as chiral carbon. So if I'm taking, if it should be considered as an optically active molecule, okay, it should not superimpose with mirror images. Okay, they are non-superimposable mirror images are called chiral molecules. Okay, now let us discuss with the example. Let's assume this is the original molecule I'm having. Okay. Now, if I am putting a mirror in between that, I'll be having the mirror images like this. Okay. Are you able to understand? This is a mirror image of this one. Okay. This is the original. This I'm taking a mirror image. So it will be like this only. Okay. Are you able to understand? Okay. If I'm superimposing it, whether it is matching, you just look at yellow ball is there and red ball is there here. And here also yellow ball is there and red ball is there. Okay. Are you able to understand? Okay. And next thing is, if I'm taking, rotating it there. So here one yellow ball is there, one violet ball is there. Here also one yellow ball is there, one violet ball is there. Are you able to understand, students? So if the molecule said to possess a chiral molecule, they are non-superimposable on its mirror images like this. If it's said to be a achiral molecule, that time all the carbon atoms, all the groups surrounded this green carbon, surrounded this green ball will perfectly match. That time it will be called as a achiral molecule. Okay, here only one position is matching, remaining 2 are not matching. Okay, that is what they are, non-superimposable mirror images. Okay, that is what they are, optically active molecule. Are you able to understand, students? So here, if suppose carbon is having 2 same groups there, that time they are perfectly matching. Okay, they are perfectly superimposable on its mirror images. If it is not a mirror images, you just by rotating it will match. Okay, that is what a achiral molecule will works. Okay, just by the way of talking about that chiral molecule or chirality, they are non-superimposable mirror images like this. Are you able to understand, students? If you consider this carbon, you assume that this is the carbon. Okay, so here one group is different, second different group is there, third different group is there, but fourth group is same group, that is second group. So these 2 are same. Okay, and here also if it is a mirror image like this, if you are taking a mirror image, so all the groups are perfectly matched with each other. That gives a achiral molecule. This is a achiral molecule. This is a achiral molecule. Achiral molecule. So achiral molecule. Say for example, if I am taking an example like this, you assume that here one molecule is there, one different group is there. Okay. Here one different group is there, but these 2 are same groups. Okay. Are you able to understand, students? So here this is what? So I'll be having achiral. So here all the groups attached with the carbon, that is all the valencies completed with the groups will not be completely different. Okay, so here one group are same, one group is same and remaining two groups are different. Okay, like this. Suppose if I'm taking one COH group is there, one OH group is there, one CH3 group is there. These three groups are different. Okay, but the same group is repeated here. Okay, this is what it attaches the achiral molecule. Likewise, this group is also be there. Suppose if I'm taking a mirror image of this, let's assume. So suppose if I'm taking a mirror image, okay. So this is the exact mirror image of this one. If you consider this the original image, this will be a mirror image. Okay, this will be a mirror image now. Are you able to understand? So here, suppose if I'm matching with this, if I'm superimposing on it, whether it is superimposing? No. So how it will be? So here, if I'm rotating that, if I'm rotating this, you just look at any of the rotation, it will perfectly match. In all the positions are perfectly matched. That is called superimposable mirror images. This is a red color and this is a violet color. This is also violet color. This is violet, 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 violet and red, red. Everything is perfectly matching with each other in any of the rotation. That time it will be called as achiral molecule. I think so you understand very well about the chirality as well as the achiral molecule. Okay, so please go forward to others to get benefit. Don't forget to subscribe my channel and please put a like to this video. Thank you so much for watching. Thank you. Thank you for learning, share and like this video.